Okay, calculus class, one thing I want to do is I want to explain the idea of the squeeze theorem. This was an important part of lesson 1-3, which remember we got caught by the pep rally. So very excited about the pep rally. Now please notice over here on the squeeze theorem, I have a circle. Notice the radius is 1, and I have this green part of the circle is called the sector of a circle, kind of like that game Trivia Pursuit or like a pizza pie. You may remember we studied that last year in our radian measure of an angle. And then notice I have two triangles here. I have a small green triangle, then I have a big like blue triangle, okay? And notice that that point would be the that would be the the sign would be the height of that triangle. Does that make sense? Okay, so what I'm going to do is I'm going to use this idea and work a problem. Now, what is that problem? That problem is we want to find the limit of sine of x over x as x approaches 0. And that's what we were going to play with in class. And you could play with that function on your calculator and see if it really is indeed 1. And of course you could do the same thing with this guy over here and see if it really is indeed 0. Also, don't forget you could watch a video here using that little scan. But anyway, if you notice that this sector area is between the area of these two triangles. So I worked this out on my own, and I was pretty close to being right. Let's show you what I did. Okay, so here is my idea of this. Here's the little graphic idea of what's called the squeeze theorem. If I have two functions, f of x and g of x, and let's just play make-believe. Let's make believe there's only one point there, okay, one point, that location. And I have h of x between them, okay? If h of x is always between them, and the limit at that location is L for f and g, what must the limit be for h? Right? That makes sense. It would have to be the same, which is L. All right, so now I'm going to take the idea of the area of a triangle. Remember, area of a triangle is space times height divided by 2. Here's my picture. Now what I did is I made a little right triangle here, okay? But you could use the triangle they have in the textbook. So the area of that sector has got to be between the area of that triangle and the area of that triangle. I mean, look, that's just as plain as day. Now, so what I'm going to do is I'm going to take theta right here, and I'm going to rewrite the triangles. Now, on that left triangle, remember that base is right here, the height is right here, and of course the radius is that 1. We're using a circle with the radius of 1 here. Here is the area of the sector, which was a formula from last year, and here I have that big triangle. We can call it ACE, okay? So a little bit of last year pre-calculus. Now, how about this little triangle? Well, the base is cosine of theta, and the height is sine of theta. And so that's what that triangle turns into. This is that formula. Remember, r is 1, so 1/2 theta would be what that's left over to be. And then this is 1/2 base times height. The base is 1. The height is h, which is the tangent of theta. Why is that? Because tangent is opposite over adjacent, and that's 1. All right, now we're going to, this sounds arbitrary, but we're going to multiply by 2 over sine of theta. When I multiply all these guys by 2, notice all the 1/2s go away, and if I divide it by sine of theta, that sine of theta goes away, so I have cosine of theta. That's just going to be theta over sine of theta, and then tangent sine over cosine, so I'm just left with cosine. Now I have these 3. Now remember, this is like g of x, and then this is like h of x, and then this is like, no, this is like f of x, and this is h of x. So I'm going to turn them around. Of course, you know, I'd have to, if they were inequalities, I'd have to turn the inequality around, but that doesn't matter. Okay, now I have 1 over cosine of theta, sine of theta over theta, and cosine of theta. All right, can we take the limit of a trig function? We just got done talking about that. Can I plug in 0? Yes, cosine of 0 is 1. So that's going to be 1 over 1. That, I don't know. That's why I set up this problem, but I know it's between these two guys. And cosine of theta, plug in 0, cosine of 0 is 1, so that's 1. So what do we know now? That is between the two of those guys, and they're both equal to 1. So by, deduction, we know that the limit of sine of theta over theta as theta approaches 0 is 1. That's a good little proof of that. Hope that helps you out. So you could use that idea to you could study this one. This one's slightly different, but remember, we've got to make sure that we use radian measure when we do that. But you could try it out in your calculator too and be convinced about that. Now, these two little theorems are extremely important, and you need to write them in your notes. We'll call them 2 special trig limits. All right, I hope that helps you out.